All right, folks, this is just a quick, I put all the math here because I don't want to get bent up about the math we did for number 2 in the solution. If you want to go through how to actually do a polar coordinate problem with the math, I would go to the solution for number 2. So here I have the same region as drawn, but this time I drew the circles so you can see them. R is always positive. Some of you had written R equals -1 to -4. And that is actually incorrect. And you just got lucky if you did the computation and you showed that you actually get the same answer, whether you're going from R equals -1 to -4. It's because of this guy right here, this integrand right here, for you was symmetric. It was x squared plus y squared. But I'm going to put just a simple x here and show you that integrating from r equals 1 to 4 is not the same as integrating from r equals -1 to -4. And so here what I did, right here, I replaced the x with r cosine theta, and this is the dA right here. And I just went through the process and I did the full computation. So if we go through, I computed the inner integral. This here is the inner part right here. And I get this 21 cosine theta. And if I go to the next line, I just copied where I had the previous answer, and I just integrate with respect to cosine, the theta, and I get sine theta. Valuate, we get 21. And that's the correct answer. If you think about what's going on, I have x, which is a plane, on top of this little annulus, and you get a shape that you're finding the volume of that's going to be positive. Now, what if I had done r equals -1 to -4? I go through those same calculations, and I get here as a final answer -21, not 21. So it's close. It's the negative of the correct answer, but it's not the same. And this is why if you had put down -1 to -4 as your limits of integration, I marked that incorrect, because setting this up in polar coordinates and putting that as your limits of integration is actually incorrect, even though it accidentally gives you the right answer at the end. And so I want to make sure that that's really solid, because you don't want to make this mistake again. Your radius is always going to be positive. So we would write, the correct way to do this is, my radius starts at the center of this region, pops out, strikes the curve at r equals 1, exit the curve at r equals 4, not -1 to 4. So please let me know if you have questions on this. It's very subtle, and I don't want you to feel like you should always take whatever happened and go, okay, I'm going to learn from that so it doesn't happen again. So thumbs up, keep going.